Hello, dear ACHEMA Pulse viewers. This is Festo calling. Hello from Esslingen near Stuttgart. My name is Dorothy Gelmar, and I welcome you to the next session here at the ACHEMA Pulse. We're about to focus on a very important topic. We will talk about efficient automation solutions for package units in modular production. And you, ladies and gentlemen, have the opportunity to interact with our experts. You can pose your questions that may appear during the presentation, which will take around about 25 minutes. So a long time for questions. I will hand them over to our experts at the end of the presentation. So take the chance. And experts, here they are. It's Valentin Buleac and Dr. Christian Barth. Hello, you guys.
Hi, Dor. Thanks a lot for the kind words or introduction, and thanks to you for tuning in to our presentation. My name is Christian. I'm working at the Festo Corporate Research Department as a software architect on digitalization topics, Industry 4.0 solutions, with a focus on modular production.
And my name is Valentin. I'm the product manager for the PA toolkit that we will present you later on. Welcome to our presentation.
Yeah, so the concept of modularization is one of the very big trends of today's automation technology. And the idea is as simple as striking. You combine sets of assets together and form a new functional unit. And this functional unit you then use in different setups and contexts. And the immediate benefit is clear. The engineering effort you're having once with your module can be multiplied in several different contexts, so it's more efficient. But this is not even the best advantage of modular production. With modular production, you can achieve super high flexibilities of your production, because you can, when you have to produce more, just add additional modules to increase your productivity or reduce the number of modules to produce less. And you can even exchange individual modules very easily to adapt your production. And you can have new production plants built much quicker because you can rely on pre-engineered modules. So this can be a very big success factor, especially when you're acting on volatile markets. So, but how does a module look like? Valentin, can you give us an example of a module?
Yes, of course. So let's suppose that what we have here is a plant, a fully grown-up plant. We have a central control system, which is on the left side of these modules. And we have different package units. The central control system, of course, the SCADA system, the different DCS controllers that are usually used in a production plant. And now let's talk about the modules, about the package units. What we have here in the middle is a classical package unit. It is composed of course, field devices, whichever devices this may be, sensors, actuators, and we will find at least one remote I/O, so where all these devices are connected to, and the remote I/O has the functionality to bring all these signals to the control system, to the main control process controller. What is the advantage of such a package unit, of such a classical package unit? Well, the advantage is on one side that you have all the functionality in the main control system. And because you are using a remote I/O on this package unit, it is fairly easy to connect from the main controller to the field devices. So there is only one cable, one Profibus Profinet cable that you usually put in the field, and you have full access to all the field devices. On the other hand, we have to keep in mind that the main controller is doing the whole job. So the main controller is really opening every single valve, is reading every single sensor. So this is the classical package unit. And because the controller, the main controller, is doing all the job, it is also the software which runs in only one place in the main controller or in the main controllers, if there are many controllers on a plant.
Okay, so very interesting. So what we're seeing here is an example of a modularized hardware. So the hardware is made in a way that it fits all together, that the components are compatible, suitable, but you still have the dependency on your main controller, and this makes the integration and flexibility not ideal, let's say. Couldn't we go one step further and also include the entire automation logic of the module inside the module itself, so that you can use it as a building block in your plant and have it more easily to exchange with others?
So this is what we have done on the second package unit that we have on the right-hand side. So if you look at the two package units from a distance, they may really appear equal. So you might not even notice a difference. Why is that so? Because if you are using the same field devices, the same components, and if you are taking a look at our CPX system, you will notice that the difference between the two systems is in fact just one device, which is the controller. So instead of the Profibus Profinet node, we are using the controller on this platform. And by doing that, we have the possibility to transfer the logic from the main controller into the local controller. So that being said, this package unit can run autonomously. So it is a self-sustained unit. Of course, it is also a lot more easier to implement a local control of the package unit, because having a controller on the package unit, on the remote I/O, you can easily get access to the visualization, to all the variables that are needed to build up a local control.
Okay, that's very, very interesting. So, but by having the entire automation logic to be done in your module itself, isn't this a big challenge for module vendors to program their own programs right at the module?
Well, we do have different kind of OEM of skid builders in the industry. So mainly there are two types. So the ones who are building the classical package unit, as I showed you before, which are controlled directly by the DCS system. But we also have manufacturers who are building the so-called skids, which are more or less self-sustained devices that can run autonomously and are doing a certain job. Let's take, for example, a filtration unit, water filtration. So these manufacturers, they already do this kind of business. So they are really programming the package units. They are programming the controller on these package units to do this job. And it will be fairly easy for them to implement this technology also when providing package units for the bigger production plants.
Okay, could you give us an example how this would look in practice?
I can give an example, because we have really developed a software tool who is well, it's taken a lot of effort for these manufacturers, so they do not really have to struggle a lot with programming the package units. And this software tool is called the PA toolkit. It is a library with a lot of templates that are giving you support when designing such a package unit, because you have a lot of features and functions that are common in process industry. And I'm going to switch over to the CODESYS environment system. This is what we are using for programming our controllers. And I can show you how this package unit, or sorry, how this library looks like, or how the functions that are inside the library can be used. So what we see here is one of those elements of our PA toolkit. So it is a function that the programmer can drag and drop on the programming editor, and it has a lot of inputs, a lot of outputs. These are mainly parameters that are being used to tell this function block what it is meant to do. So by telling it, for instance, that the units are Celsius degrees, you define this function block as a temperature sensor. And if you tell it that it should use well, liters per hour, then it is clear that this function block is then later on, or in the field, it is actually a flow meter. So these are the function blocks, or one of the function blocks that we have in our library. And we do not have only the function blocks, of course. We have visualization elements. So if I may show you this, this is how such a programming could look like. We have symbols that we can use to design the process graphic. And when going online, so that means when the controller is actually running, we have the corresponding faceplates, which gives the operator the opportunity to really interact with the field devices. Just to show you how that can look like, this is the same picture that you have seen before, but it is now in run mode. That means we are actually looking inside the controller. And we have, of course, as I mentioned before, we have the faceplates that we can open in order to operate with the field devices directly.
Okay, so that's super interesting. So what we have here is not only a modularization of the plant itself, but also modularization of the program. Right? Because you have the function blocks in which you encapsulate knowledge, and by just looking at the function block and seeing how many inputs and outputs you have for these function blocks, I imagine there are much more going on inside them than what I would naively assume. And they are automatically made compatible with the associated symbols, so that if you instantiate both, they fit together and they are automatically linked. So you can use the same patterns we have talked about in the modular production that you can easily exchange and reuse pre-engineered systems. Also here in the automation application programming, where you can rely on pre-engineered blocks, function blocks and symbols, and instantiate them very easily and reuse them in different contexts. So that's really very an awesome approach. But now we learned how simple it is to program such a module. But there's one step still missing in order to integrate such a module into a real plant. And this is what we call plug and produce, a pun associated to the plug and play concept we all know from consumer market. Because what we have there, or what we're used to there, if we use a computer with a USB adapter and we plug in a mouse, is that the mouse is automatically working, and same for a printer, right? We plug it in, the drivers are automatically loaded, and we can use it out of the box without having any manual configuration to be done. And this is exactly where we want to end up also in industries with this plug and produce context. So a driver for our modules, which is automatically instantiated and then allows a seamless integration of your model without any manual adjustments. And for process industries, we have a solution for that already, which is called the Module Type Package, or in short, MTP. And this is an emerging standard, which is being developed by the NAMOR on the one hand, the users of automation technology in process industries, a big association in Germany, and the ZVEI, which is the association of the German electric industries, so the producers of automation technology. And that's a very fruitful combination, because the first know exactly what the market needs and what the end customer needs, and the latter know exactly what is technically feasible. So the results produced here in this collaboration are both very needed and very applicable. So, and the best thing about it is not only a vendor, one single vendor which is developing this approach, but it's a multi-vendor approach. So you have a industry standard for this, and any system which is MTP compliant can work with another MTP compliant system. And the MTP approach is based on two pillars. So one being some architectural requirements. So there's one, for example, that each module has to offer some services, or its functionalities in forms of services, they're called. And there's also a well-defined finite state machine, which has to be followed by each of these services in order to make the operation of the modules straightforward and similar for each individual module. On the along on the same side, also the components, if you want to adjust or monitor and operate them manually, have to also fixed interfaces. And these interfaces needs also to be described. And this is the second pillar in an MTP description file. So this is sort of the driver for the module. So this MTP description file is a standard formalized description. It's technically implemented in Automation ML. And this file then lists all the service functionalities of the module, all the interfaces, and how to communicate with it, and what the module offers in the end. And part of this description file is also the visualization of the module, so that you can even have the local visualization HMI part in your target system then. Now this is a huge overhead, and now the question to you, Valentin. How much effort is it for a customer to fulfill all these requirements of the MTP standard, which are quite strict actually? How much does the user have to do in addition to what he's normally doing for a module you presented earlier?
Well, Christian, let me put it this way. The effort is on the Festo side in this case, because when we designed the PA toolkit, we had this in mind, and we designed it in such a way that it is fully compatible to the MTP standard. And as you said before, we are talking about interfaces between different machines, between different controllers. And well, we have OPC-UA as a protocol between the machines, but they still need to speak the same language. So that's not a protocol, these are the words, in fact, which are transferred over this OPC-UA protocol. And if we take a look again at our example that you had before, and if we are looking at one function block, all these inputs, outputs that we see here are designed in exactly the way that the standard is requiring them. So that being said, it is pretty simple to get access to all these variables, to all these names which reside in fact in a different module, in a different controller from the main controller. So it's a question about knowing what to ask in order to get the right answer. So this is what we are using here. This is standardized, and every DCS system that is actually working today on establishing this standard on their sides, every DCS system is capable of reading the information from one package unit, which is designed, in our case, with a Festo controller and programmed with a Festo PA toolkit. And you mentioned before the services. So I told you that when we are talking about a remote I/O in a classical way of speaking, the main controller is doing the whole job. So the main controller is the one opening and closing the valves, talking to the positioners, and so on and so forth. Well, this is not really required anymore when we are speaking about modular production, where we are speaking about MTP. Because in this case, the controller is only interested in one function which is available in a package unit. So that could be, for instance, a dosing function. What you really want to do as an end customer when you are designing a recipe, you just want to transfer 100 liters of water in your reactor, in your tank. So it is mainly the dosing function which is important for the recipe management system. And this is exactly what we also implemented in the PA toolkit. So that is a function that can already be used from the main controller, from the main system. It is a so-called state machine that we have there. This is something that is also, well, pretty well known in the batch industry. So it's an S88 state machine. It looks a little different in the MTP standard, but it's not completely different, just tiny differences we are talking about here. And this is how it looks like. I will not go into details because this will take way too long to explain everything. And what we are doing from the main system, if we imagine that we have well, let's say one recipe. It's just an example here. Please do not take it for granted what you see here. It's just an example to show you that this is how a recipe could look like in real life. So the recipe management system or the operator starts this recipe, and if we are taking a look here at the first step in the recipe, this is our drain function. So that means that we would like to drain to the reactor, for instance. This is a function which is being triggered inside the package unit. So the controller here in this case doesn't need to do all the steps by itself. It just tells the package unit this is what you have to do, and the package unit will then simply go on, do the job, report that it's finished, and the recipe can go on. So this is again just a small example to show you this is how it is really implemented later on in a real system.
So that's very interesting, and this also brings a new opportunity, because now the end customer only plans his recipes on high-level functionalities, right? So this means that he doesn't have to care about the actual process of the specifica, how a specific functionality is implemented in Technic. And this also has the possibility that as a module vendor, you can come with a specific process and just sell a module which is offering this functionality without telling the end customer how it's actually done in detail. And then you can shield your intellectual property of your special process, your secrets, and only offer this functionality to produce maybe a specific product, but don't tell the end customer how it's exactly done. And this possibility is also something which is very requested and demanded in industries, because this has the possibility that you can make module vendors motivate to offer their really specialized processes in a way without having the fear to lose the intellectual knowledge of it. So this is also something which is possible, and this is also something which is foreseen in the MTP standard. What is also foreseen and required in the MTP standard is possibilities, which comes a bit alongside with these considerations, that you can decide which aspects of your model you're going to show in the end, right? Because then if you want to shield your intellectual property from the end customer, you want to decide which are the components of your system which you want to display to him, so that he can maybe manually operate them, and which are the components which you might keep for yourself and only offer this high-level functionalities. So now it's the question, can we also fulfill this requirement of MTP and make a flexible, let's say, decision on which are the information we want to provide to the end customer as a module builder, and which are the ones which we want to keep for ourselves?
Yes, so of course we can do that. I will show you how easy that is to implement. When we design such a package unit, we usually have well, at least 1-2 different process graphics, and starting from those process graphics, we can build the so-called MTP description file, which holds every information that is important or that is allowed to be read by the operation system, by the central control system. So starting from those process graphics, we can decide what we really want to export. And I will show you how this looks like. And when you start this export functionality, you will see all graphics that we have in our system, in our programming, in our application, and we are able to tell what we really want to export and what not. So, as you mentioned, Christian, it is in fact so that the whole package unit might be controlled only locally, but the function itself, this dosing function that I mentioned before, is something that can be triggered from the main control system. So the main system doesn't really have an access to every field device in the package unit, which is sometimes not needed nor wanted, or even it is even so that the package unit manufacturer doesn't really want to transfer his knowledge to other systems. So this is something that we can implement very easily in this case using this export restrictions that we have in our PA toolkit.
So it's very impressive. So I'm convinced already that MTP and modular production with MTP is the future of process industries. And the MTP standard is also going to be an international standard. The IEC 63280 is the number in which this will become an official IEC standard. So modularization is a big success factor, especially when you're acting on volatile markets. And I'm convinced, and I think with this, thanks to you for your attention, and we're open for your questions. I hope there are questions. If you want to know more, don't hesitate to contact us also, and yeah.
Yes.
Perfect. Thank you, Valentin. Thank you, Christian, for these great insights. And yes, we received questions. Ladies and gentlemen, thank you for that. I'd like to pass them to you real quick. The first question is, are there systems in which one can integrate MTP modules already today?
Yes. So there are systems in which we can integrate MTP modules. So all the big vendors of process equipment, of control systems are together with us working on the MTP standard. So, and all of them having their development ongoing and developing these products, and there are already products released. Actually, already a couple of years ago, we have already released products really which are not only development state, but real released products in which we can integrate MTP modules. And we are also closely collaborating with them in pilot applications or research project to make sure that really every single step of the MTP standard, every aspect, because it's a quite complex standard, in fact, that all the aspects are really fulfilled and are working very well with all the different vendors of application technology.
Okay.
So a big yes there.
A big yes, ladies and gentlemen. I hope you heard it, and maybe you have another question coming into your mind. We have 3 minutes still left, so if there is a question, just type it into the chat, and I will receive it here on my tablet and pass it over. So 3 minutes to go. Take the chance to interact live. One more question that we received here from Lee. What exactly is exported into the MTP file, and can I influence this?
Well, I suppose this is a question that has been posted before. I answered it actually.
Maybe we can dive one more time deeper.
Yes. So this is exactly what we see here, what I explained in the last couple of minutes.
Yeah.
Starting from our visualization graphics that we have in the application, in our CODESYS application, we can really choose what should be exported in the MTP file. So if we are choosing just a graphic where the service is visualized, then only the service will be posted in the MTP description file, and this is only the interface to this function will be available in the main system for the recipe management or whatever the system is willing to do with a package unit.
Okay,
so
thank you.
Yes, again.
Yes, also a yes again. So thanks. That call to action worked out. We got another question from Paresh Kadam. Is it possible to use this control system for existing external package units and integrate with main DCS?
With the main DCS, so you, I assume the question goes in a way that you have
I can show it you one more time.
a hybrid
to
control
right.
for external package unit and integrate with main DCS. Yeah. So the question is probably in a where we have a hybrid sort of system, which is certainly one aspect which is foreseen in the MTP, to have a mixed system of classical with the DCS controller application and core process control, which is a monolithic one, because the modularization, as awesome as it is, doesn't make sense for all the applications. So, the use case, which is very, very possible and very meaningful in many situations, is to have a plant which is partially monolithic, so with a main controller, main DCS system, as proposed in these questions, and then you add individual modules into that. So this is actually something which is very exciting, and it's very, very well, it goes along with the idea of MTP, to have this mixture between a classical monolithic control system added with singular modules, which you can add and then remove also later. So this is well possible and also foreseen in the standard, yeah.
Perfect. So also a yes, ladies and gentlemen. Thank you very much for your attention. Thank you, Valentin and Christian, for all the insights. And this is not the end, ladies and gentlemen. The session stops here, but for sure you have the possibility to interact with our experts via video call, via chat, send an email. We would love to interact with you and give you more information. So please check out our platform, our company profile here at ACHEMA Pulse to get more details and personal contact. Thanks for your attention. Bye-bye.
Thank you.
Thanks.